Thank you for tuning into this fast chat on security tools and the issues we still face. My name is Daphne Krause. Today I'm speaking with Dr. Jules White, the Associate Dean of Strategic Learning Programs at Vanderbilt University School of Engineering. Jules is on the cutting edge of the computer science world and is teaching our computer scientists and computer engineers of the future all they need to know. So, Jules, you are an expert in the field of computer science and engineering. From your vantage point, why do we have as many security tools as we do?
That's a great question. So I think that when people think of security, they start thinking of technology, but you really need to step back and realize that cybersecurity is really about human mistakes. So humans make mistake in the design and implementation, deployment and configuration and use of computer systems, and other humans come and take advantage of those mistakes. And so part of the reason that I think that we see so many tools is because there's sort of an infinite number of ways that humans can make mistakes. And we tend to focus our efforts on a particular type of mistake that has been made and trying to come up with a solution to that mistake. So, what we see is that somebody starts reusing passwords. So, we invent password managers to make it easier for them to have unique passwords and to remember them. Or we see that people are, exposing their passwords. So we develop two-factor authentication to try to make it less likely that they're going to accidentally lose their password or give it up to somebody and still have their account compromised. So the result of that is that every time somebody makes a mistake, somebody comes along and builds another product to try to do something about that particular mistake. And so that creates this proliferation of all of these different types of tools that we could potentially use. And we start focusing on the tools alone. Like, this is a problem. Like, cybersecurity is about encryption, or cybersecurity is about passwords, or cybersecurity is about the software supply chain. But we forget that these are all just manifestations of different human mistakes. And every time we create new technology, we're going to have a whole new set of mistakes that are possible to make. We're going to then end up with a new set of tools that are being used to deal with those mistakes. And so we're going to have yet more and more products. And each time we add a product, we also create additional complexity that is going to probably generate yet another layer of mistakes. So I think this is our current approach is clearly going to, produce more and more security products, because it's still based on this idea of, build a product to address a particular type of mistake that humans can make in this space.
So, with that, what can be done to weed through the quantity of tools to get to the quality of tools? What should businesses be looking out for?
Yeah, so I think we still need to go back to sort of the fundamentals and realize that because this is all about human mistakes, one of the challenges that we face is we are building more and more complex systems. And we focus on what we want to accomplish, some tasks that we want automated, some new capability we're going to get, but we lose sight of we're creating complexity, and we're creating complexity that humans are going to have to deal with. And so we really need to go back and think about cybersecurity in a big way as being, how do we help humans to not make mistakes? And if we're going to introduce new software to automate something, if we're going to introduce new tools, part of that conversation needs to be, how do we make it as, error proof as possible, but also how do we make it so that when a mistake gets made, it can be caught quickly, that it can be learned from, that we want to do simple things like make it so that the right way, the secure way to use things is the easiest way to use the tool. And so if you're going to go and start thinking about products, like, well, how do you sort through all of them? I think you need to look at, is this going to reduce complexity to some degree? Is it going to help us simplify? Is it going to help us catch mistakes earlier? Is it going to help us help our users understand their actions before making them? So, like, I mean, and that's another big thing, is people don't necessarily understand the ramifications of their actions, particularly from a security perspective. So the more that we can do to help humans in this process, I think, and having a human sort of focus to this, is, the better we'll do in terms of security. So when you look at a product, looking at it, understanding, like, does this do something to help help my users? Does it help my developers? Does it help my administrators to make fewer mistakes, catch more mistakes that are being made? and without introducing its own set of complexities that will just lead to shifting the mistakes to another area.
Talking more just about software and developing a secure software, a secure application, where in this process of development is it easiest to catch those human mistakes? Where in the process can we, kind of cut down on all the issues that software is having and bad actors are now taking advantage of?
Yeah, that's a great question. Well, I mean, I think right now, unfortunately, we're in a place where all phases are producing lots and lots of mistakes. And that's a challenge. I think certain things are going to be kind of fundamental. So designing systems, the way that our software systems have evolved, it's sort of inevitable that we're going to have a hard time predicting the basically the behavior of a system. So, sort of fundamental in computer science, you build something with a modern, programming language of any real complexity. You're going to have a very, very hard time proving that that system doesn't have a mistake in it or identifying the mistakes. And still, right now, sort of state of the art is let's go stand that system up and write a bunch of tests, try a bunch of things out. It's like if when we built bridges rather than deriving and proving that it's going to be able to withstand the loads that are going to be placed on it. We said, well, we build the bridge and then we drive a truck across it. Did it fall down? No. Well, let's drive a bigger truck across it. And that's kind of where we are from a security perspective. Is like we've built the system, seems pretty good. Let's have some people try to break into it and see if they can find mistakes, or let's pay other people to go and see if they can find mistakes. But at the core of it, we can't tell you if there's a mistake or not. We can't prove it in any way, so we really rely on external people. So I think there's probably a large, there's probably a lot of potential to rethink in the future and probably figure out how to design systems to where we really do and can prove certain things of it. I think another place where there's probably a lot of potential is now that AI has gotten good at collecting a lot of this data, is to help us to basically reduce the burden on users, developers, administrators of these systems, by being able to sort through the large volumes of data. So the things that AI does really well are look at large volumes of data, simplify, identify trends, characteristics. It doesn't mean that humans are going to go away, but a lot of the things that maybe humans aren't good at, which is, staring at large volumes of data 24/7, day after day, humans get tired, they make mistakes. Like that's a great example of something that you probably don't want a human doing, because they are going to get tired, they're going to make mistakes, there's going to be problems there, whereas AI doesn't. So I think in those types of places, there's a lot of potential to use AI to help humans or to offload tasks that humans aren't going to be good at, and humans are almost guaranteed to make mistakes in. Conversely, like those really special edge cases that require a lot of thought and cognitive power, those are places maybe that AI doesn't need to be there, and we really want to free up the humans to focus on those places. So I think some of the potential is there's probably all across the spectrum, there's potential for improvements. I think one of the interesting things about AI is the ability to free up humans to focus on sort of the bigger picture of thinking about what can we do and change to make a difference. And then in these little point areas of particular problems or things where we've got humans really sitting down in the loop trying to look at all the nitty gritty, we can offload that to AI, deep learning, those types of things to make a difference. So I'm not sure of one specific area, but I think there's the potential to sort of rethink how we deploy human resources and augment them with AI resources.
So, when you talk to your students about application security, what is one thing you highlight as the most important?
I think the most important thing, so my students, are typically going to go out and be software engineers. So the first thing I want them to know is what are all the common mistakes that people make? What do those mistakes look like? How can we kind of think about them in terms of a pattern? Because a lot of the things that, if you go out and look at what's being done from a security perspective and the mistakes that are made and the vulnerabilities that are out there in applications, it's the same things happening over and over because either people aren't aware of them or they haven't stopped to think and identify what is sort of the fundamental pattern that they need to be looking for. So I think we're still in the world where the low hanging fruit is all of the mistakes that have been made over and over and over again. and are still being made. So if we can just focus at first on trying not to repeat mistakes, a lot of attention goes to, the one-off 0-day vulnerabilities, complex issues that are found in software where you had a lot of really good developers working on the system. They didn't spot it. It's something that's just very, very complex. Those are going to happen. But all the ones where it's like the SQL injection attack, the buffer overflow that are obvious and that any seasoned developer that's had experience with it could look at it, that's a place where we really need to be focusing. And so I really emphasize with students, you're going to have my data one day, probably. And the base level that I want you to have in terms of application security is not repeating the basic mistakes. If you make one of those big mistakes that's really hard to see through the complexity, that's okay. Let's try to get those basics right. If we know it's a problem, we've seen it before and it's obvious, let's not make that mistake. Let's make it as hard and as expensive for attackers as possible, because the cheapest thing for attackers is to go and take something that's already been discovered and amortize that cost against a lot of people. Those one-off exotic things, those are so much more expensive to develop, and that's what we want to force attackers into that side of those expensive things, not the cheap things that are well known. That's what I tell my students and try to emphasize in the courses I teach.
Dr. Jules White, thank you so much for your time. And to our listeners, thanks for sticking around. For more information about Rampart AI's application and resiliency solution, head to rampart-ai.com. Until next time, stay secure.